Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 14, Lesson 2, Rotational Symmetry. If you have been folding Sonobe origami units with me, you have heard me talk about rotational symmetry. And if you have been folding Sonobe units, you have been using rotational symmetry. So you have a grounded position here. For a figure to have rotational symmetry, it looks the same if one rotates it around a point that is at its center or center of rotation for less than a full turn. So before I show you the unit and get you to make all those connections, over here on the screen I have what we call a full circle protractor. The center where this intersection is, that is the center and the center of rotation therefore. And you can see that on this one, they put 0 and notice also 360 under it. And then they put that on the side. And then as we go up, we're measuring angles. We've come to 90 degrees, that right angle formed by these lines. And also right here by these line segments, we have right angles happening there. When we get all the way over, if we keep going to 180, that is how many degrees a straight line has. You can see that 180 connects along this line segment to 0. If I keep going, this is what we call a reflex angle. When I get down here to 270, that's 180 plus 90, and you can see it's folding and forming another right angle here. And if I keep going, I get to 360, which is also 0, because the end point on a circle is exactly the same as its starting point. Now, when we are doing turns, we can go clockwise, which means following the same direction as the minute and hour hand on the clock, or we can go counterclockwise, which is the opposite. Also, we can go fractions of the circle. So lovely. So now we're sticking together your fractions work and your angle work. Oh my goodness, so much good fun. If I start at 0 and go 1/4 of the way around the circle, that is a quarter turn and it makes a right angle. If I continue and go 1/2, which in this case is also equal to 2/4, think about that, your equivalent fractions, we get to 180 degrees. If I kept going from there to 270, that would be 3/4 of a turn. And if I keep going the whole way, that's what we call a full turn. Now, any shape that you turn a full turn will end up looking exactly like itself. But let's take a moment now to look at our origami unit and see what it looks like as we do turns. So here is a full circle protractor, which I hope you can see, and here's one of my origami units. So this is the inside of the unit, and for us to understand this, I tried to make the center of rotation right here. That's the center of this square. And I did that, in case you're interested, by first of all connecting this line of symmetry between the points or vertices of the square. Then I did the opposite right here, which actually was already a fold. And so here's this shape. Let me see. If this is 0, I'm going to just help us to notice what's going on by tracing these points that kind of stick out right here a little bit. And it won't be perfect, fair warning. Now I'm going to rotate this 1/4 turn. Here I go. And you will notice that these points here do not line up. It does not look the same as it did when it started. That's a quarter turn. Now I'm going to do a half turn rotation and get it all the way around. And when I do that, do you see? The points are in exactly the same spot. Wow! When I say rotational symmetry, that's what I mean. Let's see what happens if I do this 3/4 of a turn. 1/4, 2/4, 3/4. Now this is interesting. This looks exactly the same as a 1/4 turn, but it's not the same as the half turn. Regardless, we can now say for sure that your origami unit has rotational symmetry, and that's all it means. Now in your textbook, it gave us some other interesting shapes here that we are going to check and see if they have rotational symmetry. And on the smartboard I can do that by taking this little handle here and rotating it. So this is figure A, and if you look on the side of the screen, you will see its starting position. Now we're going to turn it a quarter turn counterclockwise. Does it look the same as its starting position? No. Now we will continue going another quarter of a turn to 2/4, which is equal to 1/2. Does it look the same as it did at the beginning? Yes. Let's check that 3/4 turn where we keep going for another 90 degrees. It does not look the same as at the beginning, and here we are back at the full 360-degree turn. My friends, figure A does have rotational symmetry because if I go 1/2 of a turn, it looks exactly the same. That's how I explain my answer. Let's try figure B. Same thing. Here it is in its starting place, and I'm going to turn it 1/4 turn. It does not look the same as the starting position. Let's go 180 degrees, a half turn or 2/4 turns. It does not look the same as at the beginning, does it? Let me keep going with it. I'm doing 3/4 of a turn or 270-degree turn now. Nope, not the same as the starting position. Let me get it a full turn, and now it does. Now almost every shape, actually every shape, I'm willing to go out on a limb here. If you turn it, will look exactly the same as it did in its starting position if you go a full turn. But because it doesn't look the same at any other point of its rotation, it does not have what we call rotational symmetry. I bet you can see, however, that if I were to grab a line and draw a line through the center, this shape does have symmetry. It has a line of symmetry here, but not rotational symmetry. All right, well now let's look at some polygons. So to help us with this, I've made copies of the polygon, one that's in its starting position and one that's not, so you can see as we rotate. So this top one, it's not, this is a quarter of a turn. As I turn and turn and turn, here it is all the way around, If I try to put the centers right on top of each other, you'll notice that it doesn't really have rotational symmetry. Let me keep going, that's not the same. So that green right triangle does not have rotational symmetry. What about my light blue equilateral triangle? Well, let's see, I'm trying to grab this. Let me scroll my screen a little bit. Well, that's a quarter turn. It doesn't seem to be the same there. But what if I bring us all the way around here? This is actually 1/3 of a turn. And I can see here that it is symmetrical. When I go this way, that's a half turn. It does not have it on 1/2. But what if I keep going? There's, 3/4 of a turn. It's the same. And so we can see here that the equilateral triangle has rotational symmetry. You can rotate it to get it to look exactly the same. How about this parallelogram? Not there. Not there. This is 1/2. Do you see how the green holding on thing is at the bottom there? It does have rotational symmetry. What about this rectangle right here? Let's do a 90-degree turn. Nope, not there. Let's keep going to 180 degrees. Whoa! It does have rotational symmetry. And friends, now you get to go check out your workbook, just 2 pages there, to think about rotational symmetry and see if you've developed the visual spatial understanding. We're just looking at a shape. You could figure it out. It's pretty tricky stuff, also wicked fun. If you get lost or stuck, please rewatch this video. If you are lost and stuck, fold up some Sonobe origami units and notice where you are rotating the shape to redo a fold so that it stays with rotational symmetry. You can always come see me at office hours if this is during the school year. Thanks for playing rotational symmetry with me, starting much earlier in our school year than this. We've been playing rotational symmetry ever since I started unit origami with you. It's all paying off. Keep playing math, my friends. Bye-bye.